Further maths mechanics, coefficient of restitution. Let's go. Why do we use the coefficient of restitution? It lets us describe the motion of two particles before and after a collision in terms of their relative speeds. So the coefficient of restitution E is defined as the ratio of their speed of separation to the speed of approach. In terms of variables, it will be basically the difference between the final velocities divided by the difference between their initial velocities, where you take the magnitude of that because it's relative speeds. Fully elastic collision means that the coefficient of restitution is equal to 1, and fully inelastic, where the particles stick together, so coalesce, that means that E equals 0 because they're stuck together, so they're not moving relative to each other. And you want to always define each variable, so the motion of each particle, as a velocity, not a speed, so make sure all your signs account for which direction a particle is travelling. We've got an example here, two particles, A and B. When we've got questions like these, we always have 2 points to consider, so always think about conserving momentum first, and then applying Newton's law of restitution. Here is a simplified diagram of the question at hand. So first we need to conserve momentum. The momentum before is equal to the momentum after. We're using velocities here, so we can just add momentums together technically. And then using Newton's law of restitution, so we want to find their relative speeds. So in order to find the speed of something, we need to do the positive subtract the negative, because that just allows you to add the magnitude of both variables together. So it's always positive subtract negative. And now we end up with simultaneous equations in terms of VA and VB. So let's solve them. First, we can do equation 1 subtract equation 2 to eliminate the final velocity of B. And then doing that, we'll be able to calculate the final speed of A, the final velocity actually, which turns out to be negative 0.733 meters per second. And then substituting now VA to find VB, and we find the final velocity of B to be 3.47 meters per second. So we need to give our final answer as speeds, so they must both be positive. So the speed of A is 11/5 meters per second, and the speed of B is 52/12 meters per second. And yeah, that's it.